side, you also need to take the Laplace transform, right? You need to take the Laplace transform for the whole equation. So on the right hand side is a unit step function, so this is actually 1 over s. On this side, with all the initial condition equal to 0, you end up with s squared plus 6s plus 9, and this is actually your ys. And then straight away with this, you have your ys is equal to 1 over s times your s squared plus 6s plus 9. And of course, this basically is going to be what? This basically is going to be s plus 3 squared. Okay, so if this is going to be s plus 3 squared is your repeated roots. So if you were to do partial fraction expansion, you have as plus b of s plus 3 plus c of s plus 3 squared. Okay? Alright, so like what we mentioned before, you can actually try to work it out on the left hand side of the equation. This is actually equal to 1. On the right hand side of the equation, you have your a times your s plus 3 squared plus bs s plus 3 times your c times s. Okay, so when you let s is equal to 0, okay, you have 1. S is equal to 0, you got 9a, right? Because when s is equal to 0, this term drop off, this term drop off. So your a is equal to 1 over 9. And then when you have s is equal to minus 3, so this two term will basically drop off, right? The two terms will drop off. So you have 1 is equal to minus 3c. So as a result, c is equal to minus 1/3. Okay, so how do we actually work on E?
You managed to get this yet?
I never do this question.
You do 1 and 2.
Right? How do we actually work out the
I
E?
only do part 1.
If you still remember, based on what we discussed
I know
before,
there's something
you
I
need
forgot
to
about it,
do
so I just want to- my one
differentiation of
first
taking
part, I didn't get my
the repeated roots of
Vector.
s plus 3
mine is
squared
531.
multiplied by the whole function,
the second
right? I
one
mean
is
multiplied by the whole function. So in this case here, the function is actually 1 divided by s plus 3 squared. And you evaluate it, you differentiate it, and you evaluate it at s is equal to minus 3. Okay, so what we are carrying out is ds of 1 over s, evaluating it at s is equal to minus 3, and this will give you minus 1 divided by s squared, evaluating it at s is equal to minus 3, this will give you minus 1 over 9. Okay, so once you work out all the coefficient, inverse Laplace transform, when you work it out, okay, so a is equal to 1 over 9, so this is 1 over 9, so this basically will be your unit step, right? You go back, you have your unit step, and then your b is equal to minus 1 over 9, so minus 1 over 9, b, this is e to the power of minus 3t. And c is equal to minus 1/3, so you got minus 1/3 t times e to the power of minus 3t, because you have c divided by s plus 3 squared. Yes. You inverse, when you inverse Laplace, this is 1 over 9s, so you get 1 over 9. Ut is actually indicating it's a step function. Yeah, if you don't indicate the ut, it's okay. Okay, you don't indicate the ut, it's alright. But sometimes we do indicate that, we tell you that this actually is a step function. Okay? Yes. That is always a challenge. You make a mistake at the very beginning, the right side rolls, you should not get more than 50% of the mark. Yeah. Yes.
If I no time then I need to get the ABC, how much mark do I get?
If you can work out the coefficient for all the ABC, because it's pretty much this out of 8, maybe you get about 5.
Bro,
Okay.
you tried. You tried.
Alright. I mean, I'm marking basically based on what exam is going to require us to mark. Okay, so assuming that your answer is 1 mark, and then the inverse Laplace transform another 2 marks, so you will lose basically 3 marks. Okay, alright. Okay, any questions so far? Yes. What's that?
He's only going to go through the file, right?
I don't think so.
Oh, then you already.
Huh?
Can we collect the matriculation card earlier?
What?
Can we collect the
Should
matriculation
be
card?
lah.
Okay, alright. Let's take a look at the last one. Okay, last one, basically, you're given this function cosine t between 0 to pi, and then it's basically 0 to pi to pi. Alright, and then of course, basically from this equation here, you know that your period is actually equal to 2 pi. Okay, so you're asked to sketch. So you'll be able to sketch. So this will look something like this. No, if this is 1, so this will be your pi. Okay, so this is basically minus 1. This is actually 1. Then after that, from pi to 2 pi, this is 2 pi is equal to 0. Then after that, it will start all over again. So this is basically 3 pi.
I write the line.
Okay, and then of course you will go to your 4 pi. And then of course from here you have the other one is basically minus pi. And then you can actually do it this way. Okay, so this will be minus 2 pi. Okay, so this basically is 1. Alright, so you're asked to sketch 3 cycles of the signal. Okay, so now we know that omega naught is equal to 2 pi
No, I
divided
think
by
must be
2
the minus
pi
one also.
is
I
equal
think
to
you must show
1.
the minus one, if I'm not wrong.
For what? They never say much
Okay,
minus sign.
so what is your complex Fourier series?
Okay lah, as long as
Xt is equal to summation of k is equal to negative infinity to positive infinity, ck e to the power of j k omega naught t. Okay, in this case here, we already know that omega naught is equal to 1, so we have summation of k is equal to minus infinity to positive infinity, ck e to the power of j k t. Right? Because omega naught is equal to 1. So now we go back to calculate what is your ck. Okay, so ck is going to be equal to 1 over t, and then it's going to be, in our case, minus tau divided by 2 to positive tau divided by 2, xt times e to the power of minus jk omega naught t dt. Okay, so in a way, if we were to do that, so you can actually do it depending upon how you want to do it. You can actually integrate it, right? Because tau is equal to 1 over 2 pi. So you can actually integrate from minus pi to pi. Okay, xt e to the power of minus jk t dt. Okay, so now what you have here is you have 1 over 2 pi, and then you're integrating it from minus pi to pi. So xt is equal to what? Xt is equal to cosine t, and then e to the power of minus jk t dt. So if you remember what is your cosine t, cosine t is actually equal to e to the power of jt plus e to the power of minus jt divided by 2. Okay, and then of course from minus pi to pi, you do realize it in actual fact the signal only survives between 0 to pi. Right? From minus pi to 0, the signal is actually equal to 0. So you have so this one I can actually put 4. Right? I take out the half, so I have e to the power of jt plus e to the power minus jt multiplied by e to the power minus jt dt. And of course, I can actually write it if you were to try to integrate them. So I can actually combine them together. So if I have to combine them, so I have e to the power of j. So I have 1 minus kt. Alright, so this is to take care of the first term plus e to the power of minus j 1 plus k t dt. Okay, so you have 1 over 4 pi. Okay, so now if we try to differentiate this, so this will be 1 over j times 1 over minus k e to the power of j 1 minus k t, and you are evaluating it from 0 to pi. Okay, plus this one is minus j 1 plus k e to the power of minus j 1 plus k t, also evaluating it from 0 to pi. Okay, so when you substitute, okay, so one thing is when you substitute t is equal to pi, right? When you substitute t is equal to pi, so you end up with okay. So what we can do is we can also bring out the j. Okay, if we bring out the j, so you only have 1 over 1 minus k. Alright, so now when you substitute t is equal to pi, so you have your e to the power of j times 1 minus k pi. And then, of course, the second portion of it, when t is equal to 0, you have minus 1. Okay, so that is the first part of it, and then you have minus 1 over 1 plus k, right? Because I vector out the j, I did the negative sign out. Okay, so this will be basically e to the power of minus j of 1 plus k pi, and then minus 1. Okay, so now what we need to determine is basically e to the power of j times 1 minus k pi. Okay, so if you were to write it, this is cosine 1 minus k pi plus j sine 1 minus k pi. Okay, all right. Okay, so with this, when you work it out, that you can actually see that when k is equal to 0, all right. So from here we can actually work it out. When k is equal to 0, this is actually equal to what? What do you get? Minus 1. All right. When k is equal to 0, cosine pi is minus 1. K is equal to 1. When k is equal to 1, so this is 0, this is actually equal to 1 because this is also 0. When k is equal to 2, right? When k is equal to 2, what you get here is this will be 1 minus 2 is minus pi. So pi is equal to minus pi. So as a result, sine is still equal to 0. For your cosine, what happened here is if you look at your cosine, you have minus pi, right? Minus pi is still going to be equal to minus 1. Alright, minus 1. Agree? Right, because it's going to be cosine minus pi. Cosine minus pi is actually equal to cosine pi. So as a result, it's going to be equal to minus 1. So in a way, you can actually look at this and you can actually try to work it out. Okay, so this basically will kind of give you an idea, right? When k is equal to 0, all right, you're actually at minus 1. So how can we actually write it? This basically will be something, if we were to conclude it, this will be something that is actually minus 1 raised to the power of 1 plus k. Alright? Okay, so that is basically, you need to recognize that because when k is equal to 0, you have minus 1. K is equal to 1, you have 1. K is equal to 2, you have minus 1. So if you were to change it, if you were to write it as minus 1 raised to the power of 1 plus k, what do you get? When k is equal to 0, minus 1, right? Minus 1 raised to the power of 1, minus 1. When k is equal to 1, you have 1 plus 1 is 2. Minus 1 raised to the power of 2 is going to be equal to 1. When k is equal to 2, you end up with 1 plus 2 is actually 3. Minus 1 raised to the power of 3 is still going to be minus 1. So that is something that it's not easy, but it's something that hopefully you can actually see it. So coming back, if we were to write it, so you have this 1 minus k, and then this is basically minus 1, so raised to the power of 1 plus k, and then minus 1, so it's minus 1 over 1 minus k. Okay, and then of course you can plus because minus, so you can actually plus 1 plus k. Okay, so this two will basically allow us to try to do some simplification later on. And then of course the last term is basically you have minus 1 over 1 plus k, e to the power of j. So e to the power of, okay, so we come back. So we have the other term is e to the power of minus j of 1 plus k times pi. Okay, so this is actually equal to cosine 1 plus k pi minus j sine 1 plus k pi. Okay, so now we look at this. When k is equal to 0, this term is actually equal to sine pi is equal to 0. Okay, so don't have to worry. So when k is equal to 0, this is cosine pi. Cosine pi is minus 1. Okay, when k is equal to 1, so you got cosine 2 pi. Cosine 2 pi is equal to 1 also. Minus 1, and then this is equal to 1. And when k is equal to 1, your sine 2 pi is equal to sine 0. Sine 0 is equal to 0. When k is equal to 2, you realize that you actually go back to something that is actually very similar. They actually got a very similar answer. So this one is going to be cosine 3 pi. Cosine 3 pi is going to be equal to cosine pi. is going to be equal to minus 1. So as a result, this is actually also similar. Minus 1 raised to the power of 1 plus k. Okay, so what we need to do is we might need to pretty much clean out these two terms. Okay, so you got 1, you have 1 over 1 plus k minus 1 over 1 minus k. So if you try to find out the common denominator, it's going to be equal to 1 minus k squared, right? Because a plus b, a minus b, so you ended up with, so this, when you cross multiplying them, you have 1 minus k, right? For this term, minus 1 minus k. Alright, because when you cross multiplying them, you try to find a common denominator. So this is 1 minus k squared. And then what you have here is your 1 minus k minus 1 plus k. So minus 1 plus k will give you minus 1 minus k. So you can actually see that this will basically give us this term and this term cancel out. So you get minus 2k divided by 1 minus k squared. Okay, so almost there. So that will be something that we can actually clean it out, because with the 2 you can actually cancel it out. So I need to look for paper also. Okay, alright, so if we were to continue, so you got 1 over 4 pi j. Okay, so this one, the first one we clean it out, this is actually minus 2k divided by 1 minus k squared. Okay, and then you can see that now you actually have a common factor. You also have a common factor that we can actually work it out. So this common factor is minus 1 raised to the power of 1 plus k. And then of course, here is 1 over 1 minus k minus 1 over 1 plus k. Okay, so this one, if we were to clean it out, okay, so this one, if we try to clean it out, so what will happen here is the denominator is still going to be the same, 1 minus k squared, and however, your numerator can be different. So you have 1 plus k minus 1 minus k, so it's minus 1 plus k. So this one will give you 2k divided by 1 minus k squared. Okay? Alright? So you have a common 2, so as a result, so what we can actually do is, if we were to write it, this becomes 2 pi, and then as we say, you can actually multiply it by j squared. If you want to put the j at the numerator, okay, so if we were to do that, okay, so inside what we have is we have 1 over 1 minus k squared. Alright? Okay, you have 1 minus 1, 1 over 1 minus k squared. So originally, this is basically the positive side. So this will have minus 1, 1 plus k. And then what you have here, so this is actually your k, and then this is actually minus k divided by 1 minus k squared. Okay? But of course, when you try to change the j, if you take j divided by j, multiplying the whole thing, you got j squared. J squared is minus 1. So at the end, you have j divided by 2 pi and what we need to do is we need to actually invert the sign. So you got k divided by 1 minus k squared, and this will give you 1 minus 1 raised to the power 1 plus k. Okay? Alright, so this will be your CK. Okay, this will be your CK. Your CK is eventually is going to be k divided by 1 minus k squared multiplied by 1 minus 1 raised to the power 1 plus k. So now, what is your xt? Xt is initially when we write it, xt is equal to summation of your k equal to minus infinity to infinity ck times e to the power of jkt. So in a way, what we have here is we need to actually put it in. J times k is minus 1. Then I flip the sign, right? Originally, this is like this, right? J times j. So I change the sign, so it becomes k divided by 1 minus k, and then you have minus 1 raised to the power 1 plus k. So the negative sign is actually coming from j times j. Okay? Alright? So your xt is equal to, based on what we discussed earlier on, summation of k is equal to minus infinity to positive infinity. And you also realize that in this case here, your k cannot be equal to 0. If k is equal to 0, the whole term is going to be equal to 0. So k is actually not equal to 0. Okay? Alright? And then what you have here is you have j divided by 2 pi times your k divided by 1 minus k squared. And then multiplying by 1 minus 1 raised to the power of 1 plus k. And of course, you need to multiply e to the power of jkt. So that is your complex Fourier series. Yeah. It's a hard-earned 8 marks. You can see that complex Fourier series, unless the function is actually quite straightforward. If you have any of such function, typically it's rather long, tedious. Okay, so if you roughly know how the question is going to be tailored, you will know that complex Fourier series, most of the time, when you look at it, it will go together with your Laplace transform. So if you try to avoid that, that means you must do the double integral. Okay, your double integral, your ODE, you must complete because you have 4 questions, you're supposed to pick 3. So if you want to eliminate, if you think the complex Fourier series is going to be tedious, you want to eliminate that, then you have to look for alternative because you need to answer 3 out of 5 questions. Okay, and then of course, if you eliminate your complex Fourier series, then inevitably you might have eliminated your Laplace transform. Okay, Laplace transform not difficult but easy to make mistake. Okay, typically a lot of you all make mistakes for the Laplace transform. Okay, any question? Any question with this question? No? Okay, all right. I think we'll stop here today.